Hello there guys, welcome to this video where we're going to be taking a look at groups. So we're going to be defining groups and kind of really trying to understand what they are. So let's get right into it. Okay, so in this video, we're going to be taking a look at one of the most simplest groups there are, and it's known as the dihedral group. Another way to write it is D3. And it's all to do with triangles, and specifically geometries related to triangles, such as rotations and reflections, which we're going to be taking a look at now. And for this particular triangle, there are three axes of rotation. Namely, there is one here, there is one here, and there is one here. Okay, so let's take a look at the reflection right here. So if I was to draw like a mini triangle right here, if I was to reflect this triangle, okay, on this axis here, well, the 1 is going to stay where it is, so I'm going to write the 1 here. The 2 is going to swap here, so 2 goes there, and the 3 is going to go where the 2 is, because it gets reflected, right? 2 goes there, and 3 goes there. Okay, perfect. So now let's take a look at this axis of reflection. So once again, I'm just going to draw a mini triangle here, and so 3 stays where it is, right here. And now the 2 goes where the 1 is, and the 1 goes where the 2 is. Okay. And finally, we're going to be taking a look at this axis of reflection. Okay. And so this time the 2 stays where it is, the 1 goes where the 3 is, and the 3 goes where the 1 is. Okay, awesome. So we have 3 different reflections that are happening here. And just to kind of label what each one is, I'm just going to do this. So this is the reflection there. This is the reflection there, and this is the reflection there. Okay, amazing. So now let's come to rotations. Okay, so you can have 3 different rotations as well. Okay, so the first rotation, well, what you can do is you can kind of rotate it so that the 3 goes where the 1 is, just like that. I'm just going to move this down. So you can have this kind of rotation, where the side 1 has taken the spot of number 2, and the side 2 has taken the spot of number 3. And this is essentially a 120-degree rotation. So 120-degree rotation, okay? A clockwise rotation of 120 degrees. So you can have another rotation now of 120 degrees, like this, so that the 2 goes where the 3 is, just like so, okay? So this time, the 2 is on the top, the 3 is on the right, and the 1's on the left, okay? So this is a 240-degree rotation. And finally, you can have another rotation just like so, which goes back to your original shape. This is essentially either a 360 rotation or just no rotation at all. You know, so you have a 1 here, 2 here, and 3 here. And let's just say it's no rotation at all, okay? So you don't do anything there. Okay, so guys, now what I'm going to be doing here is putting these in brackets like this, okay? So this is our dihedral group right here, D3, as it's known. So now I keep saying the word group and that this is a dihedral group. But what makes this a dihedral group? Now let's talk about this. So let's talk about important things that a group must have. So the first important thing that a group must have is a binary operation. So a binary operation. And what this is, it's simply a way of combining 2 things in a group. Okay, and obviously this thing here is a set. Okay, it's a set of elements. Okay, we have a set of rotations and reflections of this triangle. Now, a binary operation is just a way to combine 2 random elements. Let's say we pick these 2. Okay, so it's a way to combine them. Obviously, in this case, it's quite it's quite simple. All you do is you take the triangle, let's say we do this first. You would reflect it once, and then you would rotate it by 240 after that. Okay, so in this case, the binary operation is just to do the thing on a triangle. You know, do whatever action you're doing on the triangle. But there are groups where you can have numbers like 1, 2, 3, and so on, whatever. And in this case, there are many ways to combine 2 elements, right? You can either add them, you can subtract them, you can multiply them, and so on and so forth. But what makes a binary operation different is that when you combine 2 things in that set, you need to get another thing in the set. Okay, so now in this case, okay, so we're reflecting it first. So let's say this is our axis of reflection. So if we reflect it about that axis, what do we get? Well, the 1 stays where it is, the 2 comes here, and 3 goes there, which is what we have here. So perfect. And now we rotate that by 240 degrees clockwise. So this is a 180 degree rotation, and this is a 240 degree rotation right there. Okay. And now notice what we have, guys. So we have a 3 on the top, which I'm gonna write like this. We have a 2 on the right, and finally we have a 1 on the left. And voila, we literally have this element right here that came back to us. Do you see that, guys? So if we combine 2 elements, we should get another element that's in the set. And that's very important for binary operations. And this property is known as closure. So a binary operation guarantees that you have closure. Okay, so if you can combine 2 things in this set of elements, you must definitely have closure. So you can't get an element that's outside of this set. It has to be something within this set. Okay, and another condition is that it must have an identity. Okay, in this example above, the identity element is this element right here, because it keeps the triangle the same. It essentially doesn't do anything to that triangle. It just keeps it as it is. So that's known as the identity. And then you need to have an inverse, which is essentially for each of these actions that you do to the triangle, you need to have an inverse element that does the opposite. Okay, that takes it back to what it was originally, essentially. So let's take this element right here. So this is a rotation of 240. So it's a rotation of first 120 and then a rotation of 240. So the 2 ends up on the top. Okay, like this. So now to go back to the original kind of triangle where the 1 is on the top, what I need to do is I can't rotate it anti-clockwise, you know. So what I need to do essentially is rotate it 120 degrees once more clockwise like this. And I get back to where I am. And that is known as the inverse. And so this element here is the inverse of this right here. Because if I combine this and this, I just get the identity again. I just get what I had originally once again. Okay, so that is known as the inverse element. And each of these, all 6 of these have an inverse. And you guys can check that yourself. So the final thing that we need is associativity. And what associativity is, say we pick 3 elements. Technically it can be 3 or more. Let's say this, this, and this. I'm going to call this A, call this B, call this C. Okay, so what associativity is if I have 3 elements, A, B, and C, I can segregate them, right? So I can either split it up so that I have the B and the C, or I can split it up so that I split up the A and the B, and then I have the C on its own. Okay, so I have 2 ways to split it up. Now, associativity ensures that no matter how you split it up, it should always be the same. Okay, notice I'm not moving things around. Okay, I'm not moving the A's, B's, and C's around. In the top case here, I'm doing the BC first, then I'm doing the A. In the bottom case, I'm doing the AB first, then I'm doing the C. So in our above example, what that translates as is you're going to be doing these 2 actions first, then you're going to be doing the action A for this top one. For the bottom one, you're doing these 2 actions first, then you're doing action C for this bottom one here. And they both should be equal. And that's what associativity ensures. So perfect. So we have a set of elements. We have a binary operation, which is just a way to combine them, doing one after the other. And then we have 3 conditions. And the condition of closure as well, which is, you know, ensured by the binary operation. So now we're ready to define what a group is. And a group is essentially a set of elements. So a set of elements with a binary operation. So with a way to combine those set of elements such that it satisfies these 3 conditions right here. It has an identity, has an inverse, and is associative. And obviously closure is ensured by the binary operation. And this is essentially what a group is. And of course, it can get much more intricate than this. And it gets very complex, and it's a very deep and beautiful part of mathematics that I hope to make many more videos of in the future. Please like and subscribe to be able to see those. And thank you very much for watching the video, and I'll see you guys in the next video.